Okay. So what I'll do here, okay, we'll talk about um, an example. Uh, I'm just thinking, okay. So yeah. So let's talk about, okay, say we'll talk about um let's say, a shape, class shape. Okay. Now when we talk about class, okay, so you can have multiple classes, isn't it? Let me show you on Paint. Okay. So you can have multiple classes. Okay. Should you see my Paint screen, correct? Yeah. And my plan is that I'll create a class. Okay, and I'll call this as, let's say, shape. Okay, I'll call this as shape. Now, shape can be of multiple shape, right? So we can have, let's say, rectangle or circle, correct? So we will have, let's say, rectangle and circle. Okay. Now, why, if I have to use rectangle and circle, why do we have shape class? So, okay. So the reason is, let's say, okay, there are few things which are common between rectangle and shape. Okay. Things which are common between rectangle and shape, we don't have to do it. We don't have to do it duplicate two times. Okay. Since it is common, okay, we can do at a higher level itself. Okay. And which is specific to rectangle and shape, we can do it here. Okay. So that's why we generally have higher class. Now, there are properties here, okay, in class and objects. So you have properties like encapsulation. Okay, you have properties like inheritance. Okay, you have properties. What are other properties?
Polymorphism,
Polymorphism. And then
interface, interface.
interface is way of implementing. Okay, it's a class without um any content in it. Okay, but that's not the property. It is way of
Okay.
implementing property, right? So you have encapsulation, you have abstraction. Okay, inheritance, polymorphism, and anything else, right? So abstract classes are type of class. Okay, but that's not the property. Okay, so you have you know these four types of properties programming or class and object. Okay. Encapsulation means, okay, information hiding. Let me change my Wi-Fi, guys. Okay, one second. So can you hear me okay now? So you have encapsulation, which means information hiding. Okay. As a user, you don't need to know what's happening inside. Okay. We call this as information hiding. And abstraction, we call it as implementation hiding. So you are hiding information from the from the user. You are hiding abstraction from the user. Okay, so what is the difference? So what we have done so far, okay, by creating class, okay, by creating class, we are actually performing this. We are hiding the information. So this already we have seen, okay, what it means, okay, when I say class, right, okay, and I create a book, okay, and let's say I create a function, and I create a function, say hello, right, and I print hello. Now, when you create the object of this as a user, when you create b1 equal to book, okay, and now when you say b1 dot hello, right, you are not, we don't have to get into details how hello is created. Same thing when we use list, okay, we created a list and we wanted to add values, we said append, right, or you said um, reverse or sort. What are you do? You are not worrying about how it is implemented. Is it using loops? Is it using something else? We are not bothered. We are only bothered about you giving the output or not, right? So when you go to grocery store, you're only interested in whether you have the stuff that you want to buy. You don't care from where they sourced, how they got it. You don't want to get into details, right? Similarly, so that's the first property. It becomes so easy for us to use. Of course, right? It's again, generally people take example of car. Okay, when you buy a car, you only want to know where is accelerator, where is brake, right? Or where is the gear. You don't know what kind of engine it is, what happens when you press accelerator, right? What happens to the engine. We are not getting into details of making car, right? You're saying, okay, these are 3, 4 things which I need to know, and I'm okay, right? I don't have to know the implementation detail. I don't need to know the information detail. What happens when I press accelerator? What happens when I press brake? But you only know the functionality. If I do this, this is what happens. If I do this, this is what happens, right? We don't get into what information, how information is sent, how information is handled there. So this is called as your encapsulation and abstraction. Okay. Now encapsulation is simply hiding the information. That means you don't know, okay, each part of your class. Okay, and you don't know because you don't need to know. You only need to know what are different methods that you have and how I can use those methods. Your focus is okay. So in abstraction, okay, we hide implementation. Okay, so we'll see this abstraction after we implement inheritance. So inheritance is okay, inheriting properties from another class. Okay, and polymorphism is like having multiple forms. Okay, so like say polymorphism, okay, if you remember, list also has had a function called update, and dictionary also had a function called update, right? So there's same update, okay, one belonging to list, one belonging to dictionary. So logically they perform same thing, right? When you have a two list and you want to update the values of one list with another list, right? Then you say update. Dictionary, same thing. You have two dictionary. You want to update one dictionary with the values of from another dictionary. We say update. So it's like same functionality, right? Updating value, existing value with new value. But obviously the implementation will be different, right? Because when you have list, you have to deal with list kind of values. You have dictionary, you have to deal with dictionary kind of values. So from user perspective, you don't need to know the implementation details, right? So that is what we're seeing abstraction. And since it has multiple forms, see, all of these, they don't exist independently, right? They're all together. But you need to understand what I'm trying to say. Polymorphism means you have same name, but performing different activities. Okay, so update, it knows that, okay, update from list. So this is what I need to do. Update from dictionary. So this is what I need to do. From a user, it looks as if they are same. From user perspective, it looks as if they are same. My actually computer got slow. What was the last thing that we discussed? You guys remember? I was speaking here and then I realized that I'm not connected.
So you're talking about the encapsulation and then I think the inheritance.
Okay. Okay. So we'll quickly repeat. Okay. So we're talking about uh, encapsulation, which means we are trying to hide the information. Okay. You are controlling what kind of information should be passed on to the user. And abstraction is when you are hiding the implementation detail, right? So we'll take example of car, right? Or you take example of the class we write. As a user of the car, as a driver of the car, you don't need to know how the engine is made. Same thing as a user of it's a list class or book class or any class, you don't need to know how those functions are implemented, how those methods are implemented. That is called abstraction. So abstraction is the property when you don't need to know the implementation detail. You just need to know what should I do. Encapsulation is when you are trying to hide the information. So we'll see that. But I said everything starts with say inheritance, right? Inheritance is when, let's say I have you see my screen correct here. Now, I have a class here called shape, and then I create subclasses. So this is like parent class, okay, and these are like, we call it as base class, right? And these are derived class or child class. These classes are derived from this as a parent class, correct? Now you can have any level of inheritance. That means you can have for this classes, say if I call C1 and C2, C1, C2 becomes derived class for rectangle base class. So rectangle is the base class and C1, C2 are your derived classes. Correct? So advantage is if you have a property here, this property will be accessible to both rectangle and shape. No, I wanted to create as a circle, not shape. So the properties of shape is available for both rectangle and circle, right? So as a child, right, you have access to the properties of your parent, right? But if parent want, they can stop giving access to you. So this is where the information hiding comes into picture. So shape will hide the information from derived class so that derived class cannot have access, or give access to the properties so that they have access to them. Okay, so same thing is done. Let's go and see one example first, and then we'll talk again. We'll come back and we'll talk about all the four implementation or the four properties. So I have I'll create a class called shape. Okay, and okay, so I'll create a class called shape. Okay, now every shape class, okay, will have let's say values. Okay, every shape class will have some values, right? So I'm going to say def init, okay, and here I will take a as 0, okay, or I'll call it as S1, okay, side 1 as 0, side 2 as 0, side 3 as 0, side 4 as 0. That means this shape can take 4 values, and here I'm using default values. That means you don't have to give values for any one of these, right? If, as a user, you can give value to no side, right? No variables, or you can give values to 1, 2, 3, or 4, right? Because if I have not created default values, then every time you run it, shape in it, you will have to give values to all the 4 variables. So I'm saying that it's not mandatory to create or give values to all the 4 variables. Now I'm going to create 4 variables here for object level variables, self dot s1 equal to s1, self dot s2 equal to s2, self dot s3 equal to s3, self dot s4 equal to s4. Okay, so we have analyzed or we have initialized the values here. Now we will have to calculate, let's say, area and perimeter, right? So perimeter is perimeter is used for rectangular square, and you have equivalent of circumference in circle, right? Perimeter and circumference does the same thing. You are trying to understand the total outside measurement. So I'm going to call this as self dot area equal to -1. This I'm initializing the values, right? And self dot, I'll call it as surface area. Surface area becomes your perimeter in rectangle or square, and so circumference in circle. So I'm going to say self dot surface area equal to -1. Okay. Now I'm going to add, okay, I'm going to create, I'm going to create, say another variable here, another method here called print val, okay. And in print val, what I'm saying is if self dot s1 not equal to 0. Okay, I'm checking, is it equal to 0? If it is not equal to 0, I will say side 1. Side 1 equal to self dot s1, correct? And similarly, you can add s2, s3, s4, okay? For now, I'll just giving 1, okay? We'll come back and we'll add more. Now here, okay, I'm going to give def, okay, calculate area, or simply I'll say area. Now area has to be done at rectangle level or circle level, not at the parent level, okay, shape level. So here I'm going to say print, okay, area is not implemented, okay. And then I'm going to add, okay, surface area, and we will, okay, so see, you cannot have variables and function with the same name, right? So I'm going to say my area, something like this, and my surface, okay? And here I will say surface area is not implemented, okay? So this is a simple function where we have 4 variables here in the init, and 2 extra variable we are adding, area and surface area. Then you have one simple function called print val. You have my area and my surface area, okay? Now I'm going to create a class called rectangle. Now this rectangle class is a independent class, correct? Okay, but now I want it to be derived from parent class. Parent class is shape. I want the rectangle class to derive from the main class. I want rectangle class to derive. I want this to be a child class. Okay, now let's create a normal rectangle without creating a child class. Okay, so let's say here it has its own set of init values, and here I'll say here, okay, you pass 2 values to me. Side 1, rectangle will have 2 sides, correct? So I'll say side 1, side 2. And here I'm going to say self dot side 1 equal to side 1, self dot side 2 equal to side 2. And here I'm going to say create, okay, I'm going to call calc area. Purposely I'm giving different value. I'll show you the difference. Calc area, and you will say here print area is, okay, area is S1 into S2. Or self dot, right? Sorry. Okay. Self dot. Okay. Now let's call rectangle. I want to call rectangle here, right? So I will say R1 equal to rectangle, right? And rectangle will need, if I run it, it will give me error because it needs 2 values here, right? So I have to give 2 values to it. For side 1, and for side 2. Okay, I'm calling this object for this class and I'm passing two values, okay, for S1 and S2. Okay, now what happens? When I say R1 dot, okay, so you see S1, S2 are values for R1s. That's why you see these two values. And it has only one method, calculate rectangle. So when I call this, okay, you will be able to get the area here. Okay, running the wrong file. Okay, you get the area here, correct? 34 into 45. Okay, so this is independent class. This is independent class. You can have more than one class in a file. Okay, absolutely no problem. But now what I want, okay, rectangle to be derived from shape class. Why I want rectangle to be derived from shape class is rectangle has my area and my surface area. I want to reuse these two values. I want to reuse these two values. Okay, it has print val. Okay, so I want to reuse print val also. Okay, so what I will do here, okay, when I say the class rectangle, I'll put a bracket here. And in the bracket, I will give the name of the class. Right? I'm going to give the name of the class shape here. Okay. Now, to the shape, I don't have to do anything. Right? Now, if you look at your documents, your ID cards, in your ID cards, you don't have your kid's name, right? You only have your name. But when you look at your kid's ID card, they'll have the parent's name, correct? So I'm saying that rectangle, okay, is a class and shape is the parent of rectangle. This is the base class. What you put in the bracket is base class and this is derived class. Okay, so I'm deriving rectangle from base. So base becomes parent and rectangle becomes the child class. Now when you do R1 dot, okay, you see S1, S2, S3 all are getting called area, surface area. We only had calculate area, but you're able to access area and surface area both. You're able to access surface area and area both. Okay, what is happening here? You have print val also, S4 also, right? So as a derived class, as a child class, okay, as a derived class, you have access to all the properties of your parent class. You have access to all the properties of your parent class. Correct? You have all the properties, access to all the property of parent class, right? As a child, obviously, you will have access to all the properties of your parent. This is the property of inheritance. Okay, this is what you're talking about inheritance. So as a child class, you will have access to all the properties. Okay. Now I can call, a print val. Now here, since we are calling this, okay, then instead of defining S1, S2 here, okay, I can directly call the init class. Remember, you can call the init class of parent. So how do I create init class of parent? Okay, I'm going to say shape dot, okay, shape dot init. And now I will pass your values, which is S1, S2. S1, S2. Okay, S1 and S2. Okay, so what happens? Shape is called and you have value for S1 and S2. You don't have value for S3 and S4, right? So here, when now I can, let me add other four things to it. S1, if S1 is not equal to 0, or I should say not, if S1 is greater than 0, right? Negative values also we don't deal, right? So if it is more than 0, then only you print S1, S3, right? S1, S2, S3, S4. So I will put for all these four values here. S1, S2, S3, and S4. And here I'll say side 1, side 2, side 3, side 4. Okay, and this becomes S1, S2, S3, S4. Okay. Now you see, okay, I'm calling shape and I want to print the values of the rectangle. So see, print value which is in parent is available to rectangle. So R1 is the rectangle class. I'm calling parent print value. So when you run it, oops, int object has no attribute S1. Where is that error? 36. Okay. So hmm, I got something wrong here. Shape.init. Right. Sorry. I have to pass self here. Okay. Here you have to pass self. Now it should work. Yes. So see, I passed self. Okay. You have to pass. When you call this, you have to pass self. So I'm going to use these values, parent values. Parent values, so I have to give the values for this, right? So I'm taking, so for a user, this is again abstraction. Okay. As a user, you don't know that there is a parent class, there is a child class. You feel as if there's a rectangle class and rectangle class is taking two values and then you are able to print the information from the whatever you have given, right? So you are hiding the implementation detail abstraction. I don't know, I don't need to know also, right? That you have two engine and you have, whatnot. I just need to know what happens I press on accelerator. What happens if I hit on brake, correct? That's the knowledge you need to know to run your program or run your car. Here also, I just need to know, okay, that I've created a rectangle class. I can use that print val to print the values that I have passed. It is in rectangle class, or is it in parent class, or is it in parent class? I don't need to know. Second, okay, we'll create one more class called circle, let's say. Class circle. And circle is also derived from shape, let's say. S capital, right? So again, this is derived from shape class. Now here again, I will add, calculate area and this. Now your init in this case, circle will have only one value, right? Okay, circle will have only one value to pass. So I'm calling init with only S1. The radius, basically S1 is radius. Okay. Now when I create C1 equal to circle and I radius is 12, let's say. Now when I say C1 dot, it has access to all the properties of parent shape and itself. Again, I'm going to call print val. Same print val. Now you see, it says side 1, correct? It is not printing 3, 4. It is able to handle it. Now, both rectangle and circle is calling same function. Now, if the purpose is same, then why do you have to create two different functions? Right? If rectangle and circle has same purpose, same code to do it, we could have done without using shape. We could have just created rectangle separately and circle separately. The problem would have been that the logic for implementing my value or print value would have been duplicated. You have to write two different code. For same logic, you are writing two different code. So advantage here is you are avoiding the duplication. I gave just one example, but you could have 10, 5, 15 such cases, functions, methods that you might have to write which are common for both. Okay. So it is sheer waste of time, of duplicating stuff, right? And more than time, what I said was when duplication happens, maintenance becomes difficult. Maintenance because if you have to go and make changes, you have to make changes at both the location, right? If somebody says, no, don't say print here, add something else, add, my side. Now, if I have to make some changes, okay, my side or something, okay, if you have 10 copies of print val, you have to go and make changes to all the 10 copies. And you made changes to 7 and, forgot about the 3 more. You did not find it. You made changes at 7 location, but you forgot to make at 3 other location. So in computer programming, and so same thing we do in life also, right? We avoid duplicating. Duplicate has its own advantage. Okay, sometimes we do in data analysis, we do duplication. Okay, it has its own advantage. For example, if you are talking about a read operation where you only read, you don't write, their duplication is good. Let's say you have a telephone directory. Okay, let's say you want to read a book. Okay, so you can buy 10 copies of book and you put it everywhere. You put it in bedroom, drawing room, in car, everywhere, so that wherever you are, you have access to the book. It is good in read operation, but not in write operation. So if you buy a notebook, okay, and you put it to 5 copies, so in bedroom you make changes, the drawing room copy will not have a latest copy, right? This is what problem with, okay, things when you are doing edit. Edit means you should have only one copy. Otherwise, maintenance becomes a big problem. Okay. In data analysis, you are reading the data, then there, okay, duplication is fine because your focus is not on writing, you're reading. So reading, you can have 10 copies and it is easy to access 10 copies. But most of the application, you will have to make some edit, right? It's not write once and done, permanent. No, you have to come back, make some changes. Again, you have to edit, you have to come back, right? So always have one copy of your data. So it is avoiding our effort of writing 10 things, okay, 10 times if you have 10 such methods to implement. Okay, as a user, you think print val belongs to rectangle and print val belongs to circle. You don't know that they are same function, right? They're same method, right? They are called exact same method, which is in shape is getting called. Correct? So this is abstraction and this is inheritance. Abstraction, you're hiding the implementation detail. You don't know how it is implemented. You feel as if this belongs to rectangle. And inheritance because parents' properties are available for both rectangle and circle to call it. Okay, so we'll see one more example here. Okay, instead of calculate area, why not I use my area? Okay. Now, in this case, the problem is the area will be different for both circle and rectangle. I cannot have a area here and calculate area for both. Can I? No, because the area logic is different for rectangle and different for circle. It is different for rectangle and different for circle. So I cannot have a common area function. Okay. Okay. So you have to have my area and my area here. Now, what is the importance of declaring here? If shape does not perform area, like area is not implemented, then why do we have to write this? What is the purpose of writing this? Okay, good question. So let's say for a second, we don't put this area and my surface area, we will not put, okay? Let's say we have hidden, okay? We have not implemented. Now in rectangle, you have said my area and my area, you're saying self.s1. Now what is self s1? We don't know, right? So we have to declare here self.s1 or you can create, okay, object of, okay, here we are calling the parent s1, right? So it should be fine. So now when I say here rectangle, okay, and here I will say r1 dot my area, correct? So see, area is 1530. Okay, local area is called. Okay, local area is called. Now in circle, you forget to implement my area. Let's say you forgot to implement my area. Now here, when I say C1 dot, you see, you don't see my area because you have not implemented. Now every shape, okay, your objective is that every shape that is declared. Now you have a rectangle and circle, right? You can have triangle, you can have pentagon, you can go on hexagon, right? So you can have multiple shapes. So you want every shape that user is working with to have area. Every shape that user is working with area. So that's why what happens, I'm going to, okay, add area here for namesake. I'm adding area here for namesake. So what happens here? Okay, C1 will have access to area. Where is my area? My area. And when you run it, it will say area is not implemented. So you are forcing the derived class to have my area properties. You are forcing derived class to have area properties. Okay, so this is one way to enforce. Parent is enforcing that you derived class will have, the base class is enforcing that derived class should have my area function. If you do not add, then you get area is not implemented, right? And this is coming from parent. So now when you have parent my area and local my area, okay, area here is pi r square, right? So I'm going to say 3.14 into self a dot s2 s1, right? This is s1 into s1. Okay, so now there's a clash here. What clash? Circle also has my area and parent also has my area. When circle did not had my area, then it called parent my area. But when circle also has my area, it is circle. Let's say if you also have your own car and parent also has car, then you'll be using your own car, isn't it? So if the derived class also has my area and parent class also had my area, then you're going to use your own my area. You are not going to use parent. But if you did not had, in this case, when we did not implement here, okay, then it used parents my area function, correct? Area not, which is coming from parent. But when you have your own, then you will not use parents. Okay, so this is the property number 2 under inheritance. Okay, you have access to base class properties. If you have your own property, then you will call your own property, not your parent class property. Parent class property is available to you when you do not have your own. When you have your own, there's a clash, right? Both are available to you. You will always call your own, not your parents. Okay, this is inheritance. You can call parents properties when you don't have it. If you have it, then it's your property, it is getting called. In this case, okay, print val is serving, has a purpose. Purpose is that you do not want circle and rectangle to duplicate print value function, right? So you're creating one copy which will be used by both. This also has a purpose that you are forcing it. I'm creating my area and I'm not implementing anything. So I'm actually forcing rectangle and circle to have its own set of area because, okay, when you say dictionary dot update function will be available, but it is not working. So, people start complaining, okay, I'm calling your area, but you are not giving me area value. So in a way, you are forcing circle to implement. Now here you'll have 10 different copies of my area, right? Because it is required and they are different. They are not same code. They're different code. Rectangle formula for rectangle is different, for area formula for rectangle is different, area from formula for circle is different, area formula for triangle is different. So you are forcing each of these shapes, okay, derived classes of shapes like rectangle, circle, triangle, hexagon, pentagon, to have its own set of area. Okay, so properties, that two properties of inheritance we have seen, that if your parent has it, you have access to it. If you also have it, then you will use your own. You will not have parents' access. Clear so far? Abstraction is, as a user, you don't even know that print value is coming from parent class, my area is coming from, derived class. No, you feel as if everything is in circle only. Everything is in circle only. Implementation details is for the developers who's developing the class. Okay, developers who develop list class, dictionary class, they have to think which methods to use. But as a user, okay, when you develop it and you give it to your user to use it, user will just have to call, create the object and start calling the functionalities. They don't know the implementation details. So far today we have seen inheritance and abstraction. We'll stop here today and tomorrow we'll continue with same example. We will try to see other two also, encapsulation and polymorphism.